Okay, let's go ahead and get started. Hello, everyone. My name is Marcy Standison, and I'm Marketing Manager for the Developer Initiative here at Oracle. Thank you for attending today's webcast, Relationships Unlocked, an Easier Path to Oracle Graph Analytics. We are very excited to be able to share with you how Graph Studio, an end-to-end graph management and analysis component of the autonomous database, simplifies and automates graph data management, modeling, analysis, and visualization. If you have any questions during the workshop, please put your question in the Q&A area and we will answer your questions as quickly as possible. This webcast is being recorded and we will make it available shortly after the webcast concludes. Again, thank you for joining the Relationships Unlocked, an Easier Path to Oracle Graph Analytics. This webcast will be presented by Hans Feeman, Product Manager, Spatial and Graph, and Jayant Sharma, Senior Director, Spatial and Graph Product Management. At this point, I will turn it over to Hans.
Yes, Marcy, thank you for the introduction, and hello from my side as well. Thanks for joining us for this webcast. Jane and I will use the next 40 minutes or so to show you what graph technologies can do for you and how you can get started using graph features of the Oracle database and particularly the new Graph Studio in Autonomous Database. So in this session, what we want to do is we'll provide you more of an introduction, and Jane will show you live how you can actually work with Graph Studio. We'll have a slightly longer follow-up session planned on June 15th, in which we'll explain more of the technical detail. In any case, if you'd like to try out the graph features of the Oracle Autonomous Database, you can sign up for an Oracle free tier account using that link which we have on this slide. What you get with this link is actually a promotional offer which will give you access to the Oracle Cloud Infrastructure with its always free offering, plus $500 worth of cloud credits. Right, with that said, I think we're going to jump right in. We are. So let's start with a little exercise, just to see if you're all awake and alert, right? Here's a table of things that depend on each other, right? So in that table, you can see, for example, to make A, you need B, to make B, you need C, and so on, right? So let's answer the question, does A depend on F? This is actually not easy to do mentally, right? It is also not trivial to write as an algorithm because you need to search the table recursively. But if you organize that information in the table as a graph with explicit links between the different items, then the answer is actually much simpler to find and it becomes obvious, right? You can see pretty quickly, okay, A depends on D, A depends on D, D on E, E on F, so A depends on F. In fact, there's actually two different ways in which A depends on F, right? If you go from A to B to C to D to E to F, that is actually also a valid path. And this type of analysis, this kind of discovery of complex relationships, this is what graph analytics is all about, right? That kind of dependency is a nice illustration from my point of view, but the concepts, the underlying concepts, are much more widely applicable. In fact, you can basically model anything as a graph, right? Any kind of entity can be modeled as, we say, as a vertex in this graph, and any kind of relationship as an edge between the vertices, right? In most cases, you would actually associate the type with each vertex or with each edge as well, such that you end up with, say, a vertex of type person, vertex of type product, and you would have properties describing the vertices and edges, say the name of the person or part number of a product and so forth. And so that's the fundamental concept, right? And graphs have actually become very popular in recent years, not least because of the fact they don't have a fixed schema, right? So on the one hand, you can add new types of vertices to an existing graph, and you're not breaking anything by doing so, or you can add new properties to existing vertices. For example, if you want to add the Twitter handle as a new property to a given vertex of type customer, right? You can do that without disrupting the rest of the application. On the other hand, you can also answer questions such as, find me everything associated with a given vertex, right? Which in the customer example could be all the products the customer has purchased, stores he or she has visited, contacts he or she has on LinkedIn, anything, right? Depending on the relationships associated with the edges in the graph. But the main reason for the popularity of graph databases is that you can perform analytics, which are very hard to do on other kinds of databases. And if you take the screenshot on the right, by means of graph algorithms, you can, for example, identify communities, right, in an automated manner. Right, this would be like a community here. That would be like a community here, and graph algorithms allow you to automatically identify these kinds of communities. Or you can also identify important vertices in the graph, important entities. Like if you look at that graph again, this orange vertex in the middle, right? If you have this maybe is a project team, that's a project team, that vertex in the middle, if that is a single person that is involved in both projects, that person is actually very important, and you can use graph algorithms to determine kind of importance in a graph, right? Now, technically speaking, what makes graph databases or converged database such as the Oracle database different from conventional relational databases is that we treat these relationships, so the edge between the vertices, as first-class objects in the database, meaning that they are explicitly stored. Right? This is what enables fast traversal of these edges and makes it possible to determine shortest paths between two given vertices, or community detection, and the like. Right? In the following slides, what I'll do is I'll go over 4 of the specific capabilities of graph databases and explain this along the lines of how our customers are actually using these capabilities in their application. And the first capability I've actually already mentioned. It's using graph algorithms for new insight. Right? Quite a few of our customers are using graph technologies to, for example, structure or organize data from different operational systems, whether data lake or the data warehouse, for the purpose of a 360-degree view of their customer. Right? So, and by means of graph algorithms, what they can do is they can identify communities, properties, similar interests, for example. Like if you take the 2 customers in the middle here, right? These guys here, this guy and that guy, right? If the customer on the right is, say, new and largely unknown, just by the fact that a well-known customer like this one is transferring money to that other customer, into that account, and this customer is shopping at the same store as someone who's related to the first customer, and that customer is also looking at the same web pages, maybe on the company portal. That gives you similarities on different levels, which help you to be a lot more specific about your marketing activities, or help you to derive a more accurate risk score and whatnot. Right, so this is the customer 360 type of scenario, where it's just very important to be able to use graph algorithms for big types of analytics. Secondly, graph databases are very well suited for analyzing complex hierarchies. So if you take a manufacturing customer, usually what you find is more or less complex interlinked bills of material for the products or product variants, right? Specifically in automotive, where you typically have lots of variants, right? Graph database is just very good at search or aggregation along the hierarchies, can help you to example, determine whether the parts in stock are sufficient to build a certain number of products or the like. And the resulting queries, which you would use to do this kind of analysis, are usually pretty compact and therefore easy to maintain. I will show you examples later on. Another typical example actually in this domain would be to determine what would happen if a given part is not available, right? Just by computing all the top level products with the paths which end at this part would show you the impact, right? So if for example, again, you have this part down here, it's not available, what that would mean is if you traverse the path upwards, all of these three parts cannot be manufactured because that thing is missing. So this is the second type of functionality which is particularly useful in graph databases. The third capability which I'd like to highlight is that graph databases are designed to detect patterns or indirect relationships, right? Like financial services sector, our customers typically use this capability on large networks of financial transactions to identify those transactions which are suspicious or indicate fraudulent behavior and so forth. And graph databases are just great for identifying things such as circular money flows. This is something which can be indicative of money laundering, and Jane actually will show that in demo in just a moment. Or another suspicious pattern is what is illustrated in the graph on the right-hand side, where rather than transferring money directly from the account on the top left to the bottom right, somebody is splitting up the money and transferring it through various intermediate steps, and that certainly looks fishy, right? So this is the third capability, right? Pattern matching and indirect relationships. And the fourth capability, which I still wanted to emphasize here, is that because of their schemaless nature, graphs are actually great to associate entities without restrictions of a prescribed schema. Right? And this feature is something which is popular, for example, with the police forces to support investigative work. Right? If you represent all the entities in a case as vertices and create an edge for each relationship, then you can use the power of graph analytics to identify paths, find indirect connections, determine communities, and right? In the little case here, right, you can see, okay, you have the ex-wife here, which who through a phone call was in touch with a person who met someone at a gym who is the suspect in the car accident with the victim. So you have these indirect relationships which can be very useful to analyze, are very relevant in investigative work. Right? Now, all of these capabilities actually have led to quite a surge in graph database deployments, especially in the context of analytics. And if you look at the recent Gartner report on top 10 data and analytics trends, like in the last 3 years, Gartner has listed graph technologies among the top 10 trends. And unlike in previous years when the analysts were primarily emphasizing the huge great growth rates they were seeing, and so this year they were specifically highlighting that graphs are particularly popular in combination with artificial intelligence. And the reason for this is that graph analytics can actually complement machine learning very nicely. Right? If you take the results, graph analysis, indirect connections, communities, importance as measured by ranking algorithms such as PageRank or between neutrality. These can be very important features for machine learning. You could feed the results into your favorite machine learning platform. Right? If you go back to the financial services example of fraudulent transactions between bank accounts, right? One very important feature that determines whether a transaction is suspicious or not is whether the targeted account is indirectly connected to some bad actor, some account which was involved in fraudulent activity in the past. being indirectly connected can mean like 5 hops, 6 hops away and things. And this is something which you can determine very quickly using your graph database, and then feed the result into a machine learning platform like Oracle Machine Learning, run the scoring or classification, and significantly enhance the accuracy of your prediction using this input. And in fact, you can even transfer the results back into the graph database in the graph database. Right? These are just some of the use cases, and Sherry's just put the link to a free ebook which we're providing with 17 use cases into the chat. So you may want to take a look at that if you are interested in this type of scenario. Right. So what's that all to do with Oracle? Well, we've actually been offering graph technologies for many years, and the current analytics-oriented offering has been out on the market since 2016. What you will hopefully all know is that the graph features of the Oracle database do not require a separate license any longer. Right? They're available without additional charge with every edition of the Oracle database, all Wrapup cloud services. So if you have an Oracle database, there's actually no reason not to use it for graph analytics, or at least to try it out. In the past, to use the graph features, you could either install the graph server and client kit on premises, or you could use it on the Oracle cloud by installing the OCI marketplace image. And then when you do this, create your graph model, use the tools in the graph server and client kit, such as the Python client, visualization tool, Zeppelin-based notebook, and so on, to work with the graph. And then obviously you had to run, to operate and maintain this entire environment. Now, to make this easy for you to get started, we have developed what we call Graph Studio in Autonomous Database, which is a brand new offering, which is a complete database and analytics environment as a feature of the Autonomous Database, right? And that not only means that it uses the Autonomous Database as the persistence layer, but it's actually an integrated environment which we are managing for you. So it inherits all the safe self-driving, self-securing, self-repairing capabilities of the Autonomous Database. And Graph Studio includes a modeling tool that helps you to turn relational tables into a graph. It includes a based environment to work with the graph. It comes with visualization included, and so on. And of course, it's on top of the graph analytics engine, which we've had out on the market. Number of. Right. And with that, we are covering the entire analytics workflow, right from creating a graph from relational tables to moving the data into the appropriate data structures and potentially enriching the data, to forming analytics, executing graph pattern queries, collaborating with coworkers, to finally deploying the analytics workflows and scaling the environment. And what I'll do in the next few minutes is I'll go through these steps briefly, and then Jayan will show you what this actually looks like in practice. Now, I assume that most of you are actually coming from a relational background. So before we can actually start with graph analysis, the first step we need to map our relational data to a graph, so to vertices and edges, right? Graphs are different from relational technologies where you have this strict theoretical foundation, ER modeling and everything, and that you're not at all constrained in how you model graph. And in fact, the graph model is usually influenced by the kind of analysis which you want to perform. And it's not at all uncommon to start with an initial model and then refine it over time. Rather than me talking about this in theory, what I'll do is I'll hand over to Jayant, then show you how Graph Studio supports this modeling step in practice. Jayant, can you just grab the screen and just take it over from here?
Sure. Well, you might have to stop.
Go.
All right. So I can do that. While I'm getting set up here, I just want to check one thing. What is the audio relatively clear?
Yeah, audio's fine.
Okay. All right. So Hans was talking about the Graph Studio, which is a feature of the autonomous database. And I will show one of the steps, which is the first thing that you do when you want to work with graphs is you take your existing data, you model it as a graph, and then subsequently you can analyze and visualize. But how do we get to this Graph Studio in the first place? So you go to your OCI console and to the appropriate location, your region and your compartment, and you click on that instance. It brings you to this detail page, and it has this tools which gives you access to, for example, SQL Developer Web, or what's now known as Database Actions, to a place where you can access Application Express or machine learning. And in what we would be using is Graph Studio. So when you click on this, it takes you to the Graph Studio login. And Graph Studio essentially gives you access to a place to model. That is, you look at your existing data and you create a graph. Once you've done that, you just want to get a list of what are the graphs that you already have. You may want to delete them, clone them, share them, do some actions with them. Once you have a graph, you want to use them in a notebook for interactive analysis. So let's start with the modeling process. So when you click on the modeling flow, the first one is the step is you select which data you want to model as a graph. So Hans talked about the fact that one of the things that they used in the financial services is to look for patterns of potentially fraudulent transactions, like a pattern of circular payments. So we have two tables. One has got the accounts and the other has the transactions. I select those and say, these are the tables of interest. So I use the shuttle control to move it over to the right to say, these are the ones I want to model. And when I click next, what the modeler will do is inspect the metadata. And if there are things such as primary keys and foreign keys, it uses that to suggest a graph model, which in this case, it says that the vertices are the accounts, and you will have transactions among these accounts. And you can also look at, what does that model look like? You've got accounts and then a transfer that happens between those accounts. So that's the modeling step. And I will hand it back to Hans. What I will be doing in the background is actually creating a graph instance, which we will use later. And while I'm doing that, Hans, back to you.
Yeah, okay. I'll explain that in a little more detail in first.
I might have to.
I can't grab that, so you need to stop sharing.
I will stop sharing.
Okay, perfect. So yeah. Again. So right, you've seen the first step of the modeling. The second step, we actually need to create the actual data structures. That's what Jane will now be doing in background, where we're creating the appropriate data structures to run the kinds for more complex queries and to execute most of the algorithms. What we use is what we call the in-memory graph server. And to load data into the in-memory graph server, the first step is to generate appropriate data structures where we persist the information, vertices, and the edges in database tables, and then load the data from there. These vertex tables, the edge tables, they make it possible to store the data in the schemaless manner, which I already briefly talked about, and they are fully documented. So you need SQL to bulk load data into to the tables or modify data or whatever. But you can also use what we call the property graph query language on top of these tables to query or to modify the data down in the database. That's what happens in the autonomous database. And then from there, the data into, so that would be the first step, data into the in-memory graph server. And in that server, we would have the appropriate data structures to now run the kind of algorithms which I already mentioned, or execute the pattern matching queries and the like. These are exactly these two groups of things, two classes of activities are the two operations you typically perform graphs, right? Running graph algorithms is a bit like running analytics in a relational data warehouse environment, while the pattern matching side of things is more like OLTP in a relational world, right? In either case, having the graph memory means that all these operations running on the dedicated memory data structures are super fast, and that helps a lot to run all the algorithms, right? As part of the product, we've implemented over 60 algorithms, which allow you to perform all kinds of ranking, community detection, path finding, link prediction, and so forth. And these algorithms are actually parallelized to the degree that they can be parallelized. So if you compare our implementation to other graph databases, you'll find that they scale extremely well. And as I mentioned earlier, you can use their output as input to a machine learning platform, such as OML. In the on-premises product, what we're offering is actually three dedicated graph machine learning algorithms, which I mentioned here, bottom right, DeepWalk, GraphWise, BG2Vec, which are running in the graph server. This is something which we're currently only offering on-premises, but we're working on making this in Graph Studio as we speak. Right, so that's the algorithms side of things. The other thing I briefly wanted to explain is the pattern matching. So if you want to do interactive queries, pattern matching queries on graphs, what you need is a query language that actually allows you to specify the pattern. And there is no standard query language yet. It's actually an initiative which we're currently involved in. And for that purpose, what we're proposing is a language which we call PGQL, Property Graph Query Language. And if you look at that, the syntax is pretty similar to SQL, except it includes a match clause to specify graph patterns, right? In this match clause, what we use is round brackets to specify the type of vertex and square brackets to specify the kind of edge. And note that the edge can be directed, right, as indicated by this arrow. If you have a relationship such as person A likes person B, that does not necessarily mean that person B also likes person A. Like this may or may not be tragic, but in any case, you want to be able to take that into account. And so if we take the example at the top, right, here what we're looking for is all vertices of type person, which are connected through a likes relationship to another vertex of type person, which with the property of name equal to Mario. So this is a pretty simple query, which you could also do in SQL, right? At the bottom, we have a somewhat more sophisticated query, which includes path specification and, more importantly, includes a repetitive pattern for the relationship. Here at the bottom down here, this repetitive pattern, this plus sign indicates that we're looking for one or more consecutive edges of type as parent, right? And with this query, we're identifying all the common ancestors of a vertex of type person with P1 name equal to Mario and P2 name equal to Luigi. So this as-parent relationship can be one or more steps along the ancestors graph until we meet all the common ancestors, or that we identify all the common ancestors. This is actually something which is an interesting exercise if you want to code this as a SQL query. You'll notice that due to the recursive nature, it's not entirely trivial. And here, if you look at that in PGQL, this query is actually pretty compact and therefore simple to code and simple to maintain. Now, when you're done with that, to perform the analysis, what we're offering is a notebook-based environment, which is basically designed to document your work, share the results. And again, rather than me talking about how this works in theory, let me hand back to James to show you how it works.
All right. Thank you, Hans.
Sharing. Here we go.
Now we'll share my environment. So Hans talked about, what are the things that you can do with the interactive notebooks. And in the interactive notebooks, we support 3 different types of operations. One is you can have what's known as a markdown paragraph that lets you just annotate or describe what you're doing. The second is queries. So the PGQL, as Hans explained. So a PGQL query is similar to SQL, except that the from clause has a match, and a match essentially defines a graph pattern. In this case, the pattern is show me the source vertices, show me the transfers, show me the destination, and I just want to see the first 100 of those. So let's go back to, I said we create a graph, and then once you create the graph, Hans pointed out what you want to do is to make sure that it is loaded into memory so that the analysis runs a bit faster. And that's what I did. You can come in, you can click on the graph, it tells you some information about it. What are the how many vertices, how many edges, what are the properties on the vertices and edges. But more importantly, what you can do is at that point, load it into the memory or unload it from memory. And then use it in a notebook. So I'm going to open up a notebook that I created earlier. And what we will be doing, Hans mentioned that in June, we will be doing a much more detailed step-by-step. And that's essentially what the June 15th session will be about. It'll be from scratch. How did we create this graph? And what is this? And going through this notebook. So all the steps starting from getting the data into the database to analyzing the graph in a notebook. So once I've loaded the graph and created the graph, the first is just to get some idea. What is it? What are the things? It's about bank accounts and transactions that have information about the source, the destination, the amount, etc. Now we want to be looking at, are there any circular payment chains in this? And we can either just run something which finds that for all the vertices that are there, or we can start by saying, let's look at which ones we might be interested in. So one way of looking at that is saying, show me the top 10 accounts, the ones that have the most number of transactions. So in the graph terms, that is most number of edges coming in or edges going out. So we can run a query that simply gets a count of that. Once we've done that, we get an idea of which are the ones that are involved in a lot of transactions. Pick one of them, and then we can do the query which Hans said. Is there a circular payment chain that starts at this account 934, and ends at this account 934, and has any number of hops up to a maximum of 5 in between? So it goes from A to B and back to A, or A to B to C and back to A, etc. So we know that there are at least one. Let's see how many. In order to do that, I simply just say, okay, I'll take the first 4 hops, could be anything. Then I want to look at which is the penultimate account, that is, which is the one which deposited into A at the end, and I run that query. And that will show me that there are about 10 or 12 such transactions. I may want to actually see each one individually so that I can see what this pattern is. So this one, what I'm going to do is actually enumerate in this match clause every single step. So there are 5 transfers. I'm enumerating each one of them. So it goes from A to the first intermediate account, to the second, to the third, the fourth, and then finally back at A. So we execute that. And what I've done over here is, just as in the earlier, I looked at an alternate visualization, which is, the default is a force layout, but I can say choose concentric or choose radial, different layouts. And in the case of where we're looking at this transfer of 5 hops, the one that makes sense in this instance is hierarchical. And the other thing that I've done is, just so that we can identify which is the source account, we can do something known as a highlight. In this case, the highlight simply says that I want the vertex with, let me edit this, the vertex with an account ID 934. I want to change the size, the way in which it is depicted or portrayed. I want to change that icon to 3 times the normal size so that I can easily distinguish it. And then you can follow an actual chain from just the first transfer, the second, third, fourth, and then back. So that, very briefly, is the PGQL and the queries that you can do. And Hans, I'll hand it back to you now.
Yeah, if you stop sharing.
I will in just a second. Thank you. There we go.
Again. Okay, here we go. Just to wrap up on this. So you've seen how the notebook environment looks and how it works. We'll go over that in more detail in the upcoming webcast in 4 weeks' time. Just to, as I said, to wrap up on this, if you want to operate this environment, there's really not much you need to do. The whole Graph Studio environment is fully automated. The only thing you can actually control is the additional resources for the in-memory engine, and even that sort of scales automatically. And with that, you'd be sort of ready to go. And the functionality has now been out for a couple of weeks. We've been running an early adopters program on Graph Studio, where we've actually received a lot of positive feedback. This is one of our early adopters tried out the functionality, and a company called Amenity. They were particularly highlighting the scalability of the platform, so they were very pleased with that. We had Datalysis from Switzerland who were thrilled about how simple it is to get started, how easy it is to work with Graph Studio, to use it for graph analytics. And finally, Vlam is software from the US, particularly impressed with the modeling capabilities and the large number of built-in algorithms. Right, so this pretty much concludes the introductory overview. I hope we've managed to give you a bit of an idea of what graph databases are all about. It's become clear that they are pretty powerful for specific purposes, particularly complementing relational databases. They're particularly good at anything that is to do with connectedness, indirect relationships, provide you with new insight into dependencies, behavioral patterns. You can use it to provide additional features for machine learning, right? briefly talked about that. And Jane's has shown you Graph Studio in Autonomous Database with the end-to-end tooling, the modeling, managing graphs, querying graphs, using the Notebook UI, visualization in the Notebook UI. And we've briefly talked about the algorithms and PGQL as a pattern matching query language. Right? All of that, as I said, was built on the capabilities of the Autonomous Database, uses the secure and scalable graph storage and the self-driving, self-securing, self-repairing features of the Autonomous Database. And if you'd like to get your hands on this, my suggestion would be to sign up for the free tier account using the link here. That should actually also work if you already had an existing trial account. So all you need to do is to go to this short URL. And other than that, the main thing I wanted to do at this point is to invite you to join us again on June 15th for part 2 of this session. The registration is available through this short link. Yeah, let's go here, bit.ly link, and in that sort of second part, we'll have a more in-depth view at how to actually get environment set up, load and create data, how to query and analyze the graph in detail. We'll visualize things as before, and hopefully you'll have a more in-depth understanding of this environment. Until then, if you want to have a closer look at what our graph technologies actually include, what I could particularly recommend is the live labs. In fact, Sherry, I think, is live labs link already, or maybe not. I can find it at the moment. Specifically, the live labs link guiding you to all of the graph live labs. If you're not so much of a hands-on person, but you would rather like to see these things being used and explained, we have a series of webcasts on the Ask Tom website, or of course we have all the general information on oracle.com/go-to/graph, which will lead you to the landing page at the top. Right? If you're more of a Twitter user, feel free to follow one of us on Twitter handle, Spatial Hunters. We have G-Nim, Ryota, our colleague from Japan, Meli, who's kind enough to look after the Q&A today, which actually reminds me, if there are any questions at this point, if there's anything which is not clear, Jane shown, feel free to put your question into the chat. Or if you want to stay in touch with us, we had our email up on the previous page, or you join the Orchestration Graph LinkedIn if you would like to stay in touch.
Thanks, Hans. That's great presentation and demo, Jan. There's a question in the chat that says, you emphasize the ability of schema-free creation of graphs, yet the example you showed uses existing RDBMS tables, which obviously have a schema. Do you have any other examples that use schema-free data to create a graph?
Yes, so what I've tried to explain in one of the examples, the one with the law enforcement, is that you can also build your graph from scratch using PGQL, and you can add vertices and add edges as you go along in the investigative case in a police environment. That would be a typical example of a completely schema-less graph. That said, our observation is actually that most of our customers are coming from a relational world of some sort, and they would usually be at least using a semi-structured and modeled graph, which would then be sitting on top of relational tables, which would then be used as the input to a create property graph statement and go into the modeling as Jayant has shown. Right, I hope that answered the question. Jayant, do you want to add to that?
No, I think you covered it. So the example that we were showing over here was as correctly pointed out, the whole point was to show the modeling process starting with existing data, which is in your database, which does indeed have a schema. That doesn't mean that you can't use, for example, the property graph query language, which has got the insert, update, delete, to create your vertices and edges on the fly and to add or delete properties from those on the fly. That is supported. But the flow that we are showing here is starting from data in your database, the tools that help you create a graph, and the tools that help you analyze and visualize it.
Great. So I have a couple of other questions here. The first one is, if I have an autonomous database, do I have to pay extra for Graph Studio?
Okay, so Graph Studio, in terms of licensing, is actually included in the autonomous database, right? You would find it just like the other tools, like developer web or database actions as it under tool, and there is no additional license.
Okay, great. I like free. The next question is, can I use Graph Studio for machine learning?
Okay, so what I've briefly tried to explain in the slides is that there are two different ways how you can actually use graph analytics in conjunction with machine learning. The one approach is to actually derive metrics, say per vertex, by means of graph algorithms, looking at whether an account is connected to a bad actor in a direct manner or that sort, or if the customer belongs to a certain community. These metrics can be used as the input to Oracle machine learning or maybe other machine learning platforms. They essentially characterize the graph or individual vertices in the graph or edges for that matter. That is one way to complement machine learning with the output from graph algorithms. There is also the additional possibility to directly use combined graph machine learning algorithms, which we have implemented into Graph Server, where I briefly pointed out that this functionality at the moment is only available in Graph Studio. Is only available in the Graph Server client kit for use on premises or on the Oracle Cloud in a user-managed environment, while we're still working on implementing this in Graph Studio. But again, Jane, anything for you from your side to add?
No, that's it in a nutshell. It is feasible with the Graph Server and Client Kit. It is on the roadmap for Graph Studio.
All right, okay. More questions? Anyone else with questions?
Yeah, we have a couple more here. How can I get started with or try Graph?
Okay, so my recommendation would actually be to use the promotional offer, which I've referred to earlier, and which you can the link to which you can find in the chat to set up your environment, and then use the live labs. Try out the live labs. You got the link. If you're more of a hands-on person, if you want to get started, that I think is the easiest thing. It is if you haven't seen the Oracle Live Labs, it is a wide variety of workshops covering all kinds of aspects of the Oracle database, and there's a number of them. associated graph technologies, which essentially guide you through the setup and a complete workflow, end-to-end, step-by-step, in a really detailed manner, so that you can try this out in your own environment while going through the exercises online. That is probably the simplest thing for, let's say, for the practitioner to get started.
Awesome. Okay, well, I'm out of questions. Any more questions? Put in the chat or the Q&A. Sorry. I'll give you a second to do that. If there are no more questions, I'd like to thank Hans and Jayant for this great presentation today. Just to make sure you know that we are recording this session and we will make it available, and you will receive an email in the next couple of days. And again, if you have any questions, feel free to contact the speakers directly via the links that are provided on the slide here, or on this slide. Great. Well, if there's no other questions, we'll go ahead and end the session today. Thank you for being with us today on this webcast, and we hope you have a great day.
Great, thanks a lot, also from my side.
Thank you.